In this video, we're going to talk about permutations, and our essential questions are: what are permutations, and how can permutations be used to find probabilities of compound events? So we're still talking about compound events and finding their probabilities, but now our situations are getting a little bit more complex, and we're going to be talking about permutations. So here's an example of when we might use a permutation. So I have three runners, runner A, runner B, and runner C. How many different ways can these runners finish first, second, and third place? Well, there's a lot of combinations here. So what we're going to do is we're going to make a list, an organized list to see how many different ways these runners can finish in first, second, and third place. Well, the obvious way would be A finishes first, B finishes second, and C finishes third. That's one way they could finish. Now I'm just going to keep A in first place and swap C and B. So they could finish A, C, B, first, second, third. Now there's no other way that runner A could finish first place, so we're done with runner A in first place. Runner B could get first place, runner A could get second, and runner C could get third. And then runner B could get first, and then I could swap these two and have runner B first, runner C second, and runner A third. And those are the only two ways that runner B can finish in first place. Now, the only choice I have is if runner C finishes first place, runner A gets second place, and runner B gets third place. And then I can swap second and third place to get C, B, A. Now, these are all the possible ways that these runners could arrange themselves in first, second, and third place. There is no other way to do that. So there are 6 ways that these runners can finish first, second, and third place. Well, that seems pretty easy. Let's make this a little more complex. How many different ways can these 4 runners finish first, second, and third place? Well, if I try to use the same strategy, I can do runner A, B, C, and then swap them A, C, B. But then I've got runner D, so I could have A, B, D, A, D, B, and then I could pair up C and D with A, C, D, and A, D, C. So there are 1, 2, 3, 4, 5, 6 ways that runner A can finish first place. There are also 6 ways that runner B could finish first place using the same logic. And there are 6 ways that runner C could finish first place. And there are 6 ways that runner D could finish first place. So that is 6 times 4, so there's 4 runners, or 24 ways these 5 runners could finish first, second, and third place. Now these numbers are starting to grow pretty quickly. Now what if we added yet another runner? What if I had 5 runners? How many different ways can these 5 runners finish first, second, and third place? Well, if I try to make that list, you can see this gets long very quickly. Now here are all the ways that just runner A can finish first place and other people finish second and third place. There are 12 ways that runner A could finish first place. And if we continue with this list, we're going to see that there are 12 ways. So A has 12 ways to win. B would also have 12 ways to win. C would have 12 ways to win. D would have 12 ways to win. And E would have 12 ways to win. That's a total of 60 ways that these runners could finish first, second, and third place. Now, these numbers are getting quite large. Now, we need to be able to figure out a faster way to do this. Is there a better way we can calculate how many different ways we can arrange these runners? And the answer to that is yes, and it's called a permutation. Okay, a permutation is an arrangement or list of objects in which order is important. So when we swap 2 runners in first or second place, that meant something different. So the order in which the runners finish is important. So when we rearrange them, it's a different outcome. So permutations tell us how many ways things can be arranged. How many different ways can you arrange things? And that's what a permutation is. So how do you find the number of permutations for a given situation? Well, we're going to use the fundamental counting principle. Thankfully, we can use multiplication to help us find the total possible ways. Now, it's a little tricky to figure this out, but it makes sense. Here we're going to multiply the number of objects that we're arranging. So we've got three, if we're choosing three different things, we're going to be multiplying three different things together. And then we simply multiply the number of choices we have for the first object times the number of choices we have for the second object times the number of choices we have for the third object, and so on and so forth if we picked more than three at a time. So let's jump back here to this situation and let's think about using the fundamental counting principle. So we are selecting first place, second place, and third place. So we're choosing three things. We're arranging three runners, okay? And we've got 5 runners to choose from. So how many different runners could possibly finish first place? 5. There are 5 runners that could finish first place. Well, once a runner finishes first place, how many runners now are available for second place? There's only 4 runners that could finish in second place now because somebody already finished first. You can't get first and second, so you're not included anymore. Now there's only 4 runners that could finish second place, and then that leaves how many runners as a possibility to finish in third? That'd be 3 runners left to finish in third. Well, the fundamental counting principle says then if I have 5 choices for the first place, 4 choices for second place, and 3 choices for third place, how many total possible choices is that, or arrangements is that? Well, 5 times 4 is 20, and 20 times 3 is 60. There is our 60 different ways to arrange those. So really we're going to use the fundamental counting principle, but now it's just a slightly different way to apply it. We're going to be using multiplication, but the number of choices we have each time goes down. So remember the runners in a race with 7 runners. How many ways can the runners end up in first, second, and third place? So now let's extend this again. This is going to be a lot, but thanks to the fundamental counting principle, we're going to be able to figure this out. So if I have 7 runners to choose from, and we're going to arrange them 3 at a time, first, second, and third place. So I have 7 runners choosing 3 at a time. How many runners can possibly finish first place? 7. Well, once somebody finishes first place, how many runners can finish second place? 6. There are now 6 runners that could finish second place. And then that leaves 5 runners for third place. And then the fundamental counting principle says if I multiply those together, that will tell me all the different ways that the runners could finish in first, second, and third place. And if you multiply 7 times 6 times 5, that's 210 different ways these runners could finish first, second, or third place. So again, thankfully, we don't have to make that organized list and try to figure out all 210 possible ways they could be arranged. But the fundamental counting principle and permutations tell us how many total ways there are to arrange those runners. So here, in how many different ways can the starting 6 players of a volleyball team stand in a row for a picture? So we're rearranging these volleyball players. How many different ways can we arrange 6 players? Well, we're choosing all 6. So we have 6 players, and we're going to arrange 6 at a time. So I have 6 blanks here. 1, 2, 3, 4, 5, 6. Those represent the 6 volleyball players we're going to line up. Well, how many players can I choose for this position right here? So I'm starting and I'm going to put them in order. So I've got 6 girls to choose from to put here. Well, once I put somebody on the end, how many girls do I have to choose for the next spot? 5. And the next spot? 4, 3, 2, and then once all of those are set, I only have 1 girl left, and that's only one possibility for the other end. So here, the fundamental counting principle says I should multiply all of these together to find the total possible ways to arrange those girls. Well, 6 times 5 times 4 times 3 times 2 times 1 is 720. There are 720 different ways to arrange 6 girls in a line. Now that's a lot. And again, this is much better than having to list out or try to figure out all the possible ways we could arrange those girls. So here's a little bit of notation, how we write permutations in a short, compact way. Now, permutations are written very much like probabilities, unfortunately. Now, I really wish they wouldn't write permutations like this, because this looks like the probability of 10 and 4. But really, when we talk about permutations, it's how many ways can you permutate or arrange 10 things 4 at a time. How many ways could you arrange 10 things 4 at a time? So that'd be kind of like, how many ways can 10 runners finish in first, second, third, and fourth place? So that's the notation there. That's how we write that, and that's how you see that. So let's find the number of permutations for each situation. So the P1212 here means I have 12 items and I'm arranging them 2 at a time. So how many different combinations or how many different ways can I arrange 12 things, but I only take 2 at a time? So this might be like, I have 12 students in my class. How many different ways can I choose a president and vice president from that class? So I have 2 things that I'm arranging. So I'm going to put 2 blanks there. And how many choices do I have for the first blank? I have 12 items for the first, and that leaves 11 for the second. So then 12 times 11 is 132 ways. There are 132 ways to arrange 12 things 2 at a time. Okay, that's what that means. So here I'm arranging 4 things 4 at a time. So again, it's kind of like the volleyball players. I'm putting 4 people in a row, and I'm going to arrange all 4 of them. So I'm going to put 4 blanks here because I'm arranging 4 at a time. And I've got 4 choices for the first position, 3 choices, 2 choices, and 1 choice left for the last item that I'm arranging. So the fundamental counting principle says 4 times 3 times 2 times 1. That's 24 different ways I can arrange 4 things, all 4 at a time. And then lastly here, the permutation of 10 things taken 5 at a time. So I'm arranging 10 things and I'm taking them 5 at a time. So I'm only going to arrange 5 things, but I've got 10 choices. So I'm going to put 5 blanks here. So that tells me how many blanks to have, how many I'm taking at a time. And then this tells me how many choices I have for the first item. I've got 10 things for the first item. That leaves 9 for the second, 8 for the third, 7 for the fourth, and 6 for the fifth. Fundamental counting principle, multiply all of those together, and you get a whopping 30,240 different ways to arrange 10 things 5 at a time. Now that is a lot of possible outcomes. Thank you, fundamental counting principle. So let's see now how this applies to probability. Permutations help us find the total possible outcomes, just like the fundamental counting principle, okay? So Ashley's MP3 player is set to play her playlist in random order. She has a playlist that contains 10 songs. What is the probability that the MP3 player will play the first 3 songs in her playlist in order? So we've got 10 things to choose from, and we're going to arrange them 3 at a time because we want the first 3 songs. So this is 10 things arranged 3 at a time. So to find that, we're going to leave our blanks for our first song, second song, third song. How many choices are possible for the first song? There are 10 possibilities for the first song, and once that one is played, there are only 9 possibilities for the second song, and once those 2 are played, there's only 8 possibilities for the second song, or the third song, sorry. So there are 10 times 9 times 8, or 720 different ways that her playlist could play the first 3 songs. So what's the probability that the first 3 songs in her playlist get played in that order? Well, there's only one way to do that out of the 720. So the probability that Ashley's MP3 player plays the first 3 songs in order is 1 out of 720 possible ways. So again, using the fundamental counting principle and permutations to find the total possible outcomes. 2 different letters are randomly selected from the word math. What is the probability that the first letter is M and the second letter is H? So we're trying to find the ways that we can arrange the 4 letters of math 2 at a time. So I've got 2 at a time, and I've got 4 choices for the first letter. I could get an M, an A, a T, or an H. And once I pick that letter, I only have 3 choices for the second letter. So that gives me 12 possible ways I could pick 2 letters from the word math. And the probability that the first letter is M, now I'm going to really mix you up. The probability that the first letter is M followed by H. Now this is probability and this is permutation. That's what I hate about that, is that these look identical, but this one is probability and this one is permutations. The probability that the first one is M and the second one is H is 1 out of 12. And there is our probability. So using permutations and the fundamental counting principle to help us find more compound, the probability of compound events.